college. If you're someone who's more inclined towards physics and mathematics, yes, you have made the right.
Hello and welcome. Thank you for visiting TARUC. My name is David. I am a lecturer with the Department of Mechanical Engineering, and every year we get a lot of questions about the difference between mechanical engineering and mechatronics engineering. So hopefully I can clear some of that up for you today. Now, the first thing to understand about mechanical engineering is that it is very wide and very broad. And you might be covering topics such as vibrations, mechanical design, heating and cooling, material science, things like this. And as a mechanical engineer, you might be working on projects such as oil and gas. You might be working on air conditioning systems, water pumping system, or even engines for racing cars, things like this. It's a lot of knowledge to cover, a lot of topics to master, and it's really very broad. On the other hand, mechatronics engineering is a bit more narrow, a bit more focused. And as the name implies, mechatronics engineering is a mixture of mechanical and electronic engineering. And as a mechatronics engineer, you will be more concerned with automation, industrial control, robotics, telecommunications, things like that. Working as a mechatronics engineer, you might invent the next generation of self-driving car, or you might create an industrial robot that can work side by side with a human and increase productivity for the factory. Now, whichever discipline you choose, what's important to remember is that engineering is a transferable skill. At TARUC, we don't just give you the knowledge that you need, we also teach you how to think critically, how to analyze problems, how to develop solutions. And that means that wherever you go next time, you are going to have a promising career ahead of you. So I hope that answers some of the questions you might have about the differences between mechanical and mechatronics engineering. I will see you when the semester starts.
Hi, future Tarsians. We are going to talk about the topic, what is the difference between mechatronics and electrical engineering. Before we talk about this topic, we are going to talk about the common misconceptions. Does it mean that mechatronic engineering is the study of mechanical engineers and electronic engineering, and then combine both of them, then become mechatronics engineering? Then we study half of it mechanical, half of it electronics, join together, become a rojak. Does it mean like this? No, that is not correct. I'm going to show you what a mechatronics engineers will do. Basically, mechatronic engineers will study about mechanical system, electronic system, computer system, and a control system. I know that it's going to be difficult to understand, so I'll give you an analogy. So taking a human as an example, a human, we have the muscular and also skeleton as our body. So that is a mechanical system. If with just a mechanical system, we cannot do anything. We need our brain, which is like a computer, which to control our human body and also the movement. But with just two of these, we cannot become a fully functioning humans as well. We need our nervous system. The nervous system is going to giving us some feedback. So for example, when touching something hot, so we feel it and then we do some response. So this is the control system. And the electronic system is the supporting system which connect everything together and become a complete human being. So come back to what the mechatronics engineering will studies. Basically, mechatronics engineers is the unique person which bring together all these systems and make it works. So these are 4 individual systems. We cannot expect them to put them together and then it work the way we like. So what is the job of the mechatronics engineer is to uniquely and precisely engineer it and then combine all these systems together and then become a fully functioning system. It's like a piece of missing puzzle. To bring all the puzzle, it becomes a full pictures. So this is the standpoint of a mechatronics engineers. You are the person we are looking for. We welcome you to study Mechatronics Engineering with TARUC. I look forward to see you soon.
Hi everyone, a very warm welcome to the future engineers of Tunku Rahman University College. If you are someone who's more inclined towards physics and mathematics, yes, you have made the right choice of picking mechanical engineering as the program of your studies. I'm here to run you through about the courses that are offered in this program. The various courses offered are Statics, Dynamics, Theory of Machines, Engineering Drawing and CAD, Engineering Design, Engineering Materials, Strength of Materials, CNC and Workshop Technology, Manufacturing Technology, Manufacturing and Operation Systems, Automation and Production Systems, Thermodynamics, Applied Thermodynamics, Heat Transfer, Fluid Dynamics, Applied Fluid Dynamics, Computational Fluid Dynamics, Project Management and Finance, Entrepreneurship, Engineers and Society, so on and so forth. The exciting part of this program is you are engaged in capstone project, industrial training, and final year project in the year 3 and year 4 of your studies. These courses allow you to maximize the knowledge that you have imbibed from the various courses that I have mentioned, creating an expansion, preparing you as a full-fledged, wholesome engineer.
Hi everyone, my name is Chu, the program leader of the Mechatronics Engineering program. I always get questions from potential students that will ask me, what are the courses that will be studied in Mechatronics Engineering program? So before I answer this, I would like to ask you all one question. What is mechatronics? So basically, based on the mechatronics, the word itself, we can see that it is actually the combination of mechanical and electronics. So in this program, we are actually learning courses from both mechanical and electronics engineering field. Examples of courses in this 4-year degree program are the engineering drawing, engineering design using SolidWorks, AutoCAD, programming language C++, Python, CNC machine, G-code, M-code, programmable logic controller, or in short we call it PLC for industrial control, microprocessor, microcontroller, design of robotic systems, as well as the design of automation systems. If you are wondering what is automation system, I can give you a simple example here. Example is the escalator. I believe all of you seen the escalator before in shopping mall. Okay. So when you are far from the escalator, normally you will see that the escalator is stopped or not moving at all. But when you are approaching the escalator or close to it, you will notice that the escalator will start to move. And this is what we know as automation system, because the escalator is automatically moving without any operator. Nobody is turning on the escalator or turning off the escalator. The escalator is on because the sensor detects the presence of the human. When the human is approaching the escalator, it will turn on and move the motor automatically. And this is what we call automation system. Other than that, in 3rd year, all students are required to go for internship in this program. So you will be joining some of the companies and you will learn and get to know what are the real industry, real engineers. Okay? And in 3rd year also, you will be learning some. You have a course, okay, we call capstone project, where you will work with your friends or your classmates to complete a certain prototyping from sketch design, drawing, up to the fabrication of the prototype. And lastly, of course, you need to demonstrate your work to the outsiders as well as lecturers. And in the last year or your final year, you will be doing the final year project. And this final year project, some of the titles are actually related to the industry. So you will have a chance to actually solve the real industry problems through the final year project. And after graduating from this program, you will be able to straight away dive in the industry and work as mechatronics engineer. So you can able to perform system integration or help the companies to automate their systems. So I hope you get some intuition, okay, for the mechatronics engineering. I hope you know now what is mechatronics engineering about. So I will end my video here, and thanks for watching.
Good day everyone, I'm Dr. Rahman, and today I'll give a brief overview on the courses that will be studied in Electrical and Electronics Engineering program. Due to time constraint, I will be introducing them in a group. Let's start with the electronics courses. You'll learn about the fundamentals of circuit laws such as Ohm's laws, Kirchhoff current and voltage laws, Thevenin and Norton equivalent circuit, AC and DC power, Laplace and Fourier transforms, and two-port network representation. You'll also study about amplifiers, oscillators, and transistors, all sorts of logic gates and their implementation, as well as microprocessor architectures and characterization. In the elective subjects, you'll learn about memory interfacing, I/O interfacing, semiconductors, solid-state operations, and also PN junctions, microcontroller selections, and its implementation. You'll also learn to manipulate image, videos, and audios. You also learn about FPGA and VLSI, which is the technology used to create integrated circuits such as microchips. On the other hand, in the electrical courses, you learn about power transformers, how electricity is generated using AC and DC generators, single or three-phase circuits, transmission line parameters, power flow diagrams, power factors, and how electrical energy can be utilized efficiently. Renewable energies such as wind and solar power, conversion of AC and DC and vice versa using inverters and rectifiers, analyze the efficiency of AC and DC motors as well as control systems. In the elective subjects, you learn about designing control systems, dielectrics and electrical insulation breakdown phenomenon, learn about how power can be transmitted and distributed to the customers, various power protection schemes to ensure system stabilities, and also methods to monitor the power quality. You also learn about highly relevant engineering subjects such as how to work with digital signals, learn about electromagnetic spectrum, how to use computer-aided design software such as AutoCAD to draw engineering designs, numerous machine learning algorithms, including the very popular deep learning. Since engineers are required to speak fluent English and have excellent mathematical skills, there will be a wide range of English and mathematics subjects included in this course as well. Once you completed your undergraduate studies, you have acquired the fundamentals of electrical and electronics engineering and become a well-rounded engineer ready to venture into the industry and work towards being a professional engineer. All the best!
Hi, this is Dr. Yoko Shen. Today's question is, what are the industry that our graduate would work in after they have graduated? The quick answer to this question is, you can work in semiconductor company, telecommunication company, printed circuit board manufacturers, solar panel manufacturers, electrical installations, oil and gas, and others. Well, there is also a long answer. But before that, let me describe to you what are the industry trends nowadays. Okay, our government has recently put a lot of emphasis on the Industry Revolution 4.0 and Internet of Things. Okay, you might see this term you will definitely see this term in this Rancangan Malaysia ke-12 and also in the National Policy on Industry 4.0. Okay, which has been published in 2018 by MITI. Well, so what are those things? What are those concepts? Right. Many industry processes nowadays are computerized, but they are not smart. The Industrial Revolution 4.0 concept is coming this way. Okay, they wanted to make the process smart. The computers has certain degree of intelligence. Okay, and every equipment and sensors has to be online. Okay, the Internet of Things concept here. Right? Because in order to to make this reality, okay, to make this revolution reality, you need a specialized infrastructure. Okay, what kind of microprocessor chips that can run artificial intelligence efficiently? How do you ensure the connectivity is seamless? Okay, we have 5G as the solution for this, right? Well, there are a lot more I cannot describe in this short video, but one thing for sure is that the engineering industry landscape is going to be very interesting in the next 10 and 20 years. So the question now is not what you can do, what industry you can work in, okay? But the question becomes now, do you want to be part of the industry that is full of excitement? Thank you.
Hi everyone, I am IR Dr. Vijay Prakash. I am going to talk about progression route after your engineering degree. So basically, you can focus on academic side or industry side depending on your preference. So if you are focusing on academic side, basically you are going to take your master's degree and then continue with your PhD. After you got your doctorate degree, you can work as a full-time researcher in any big universities in Malaysia or international universities, or you can become a consultant engineer or full-time researcher in any big companies in Malaysia, or also you can also become a lecturer in any universities around the world. So that's one part. Another part is becoming an engineer in industry. Basically, you're going to apply technological and mathematical knowledge that you learn in your degree course to develop, design and test performance of any systems that you are working on in your respective companies. Also, you can also choose to become in management side or more to consultancy side, and this one is if you are going to aim for senior positions in your company. Also, whenever you took your engineering degree, you must aim for IR certification, either from academic side or engineering side. It's actually both also have different route. So in order to get IR certification, you need to have a certain numbers of years of experience that you have to get through research or engineering work in your company. So there's a lot of job prospect in the engineering world. It doesn't matter it's electrical, mechanical or mechatronics. It's all up to you, your preference. What are you interested in to work in? Thank you.
Hi there, this is Cho from Faculty of Engineering and Technology, Tunku Abdul Rahman University College. You must be now puzzled with so many choices that has been offered by tertiary educational provider out there, and probably this may be due to your personal interest, which you haven't fixed it yet, or it may be due to a reason that you are still puzzled with whether the field that you are actually choosing now, whether is it you end with a promising career. To help with that, maybe you should know that Tunku Abdul Rahman University College has established since 1969, and ever since then we have been providing tertiary education services with an excellent track record in the employment rate. Also, just recently, we have retained our Premier Digital Tech University recognition awarded by Malaysia Digital Economic Corporation, MDEC, for the second time. So this reaffirms our status as the top institution of higher learning which provides first-class theoretical and practical training in digital technology. For engineering, over 90% of our graduates are able to secure a job as soon as 3 to 6 months after their graduation. And from our second survey on the working graduates, over 60% of the respondents has shown that they have achieved career advancement as short as 3 to 5 years after they have started working. Engineering is one of the few that you can worry less about its employment after graduation, simply because industry and manufacturing is still one of the largest sectors that contributes to the GDP of the country. A simple search in JobStreet will reveal the vast opportunity out there for engineering. To get started with engineering in Tunku Abdul Rahman University College, simply visit here or you may scan this QR code. It is indeed our pleasure and honor to grow with you along your path towards success. Thank you very much for watching. Bye.
Hi, I'm Dr. Steele, Principal Lecturer at Mechanical Engineering Department, Faculty of Engineering and Technology, Tunku Abdul Rahman University College. Now I'm here to talk about how our engineering program helps students to support as engineer. Now our programs are targeting technical competency, lifelong learning, and commitment to professionalism in engineering practices. Now our programs are EAC accredited and are structured with good balance between technical and non-technical skills. Now to develop students' technical skills, now besides delivery of conventional lectures, now TARUC University College is equipped with a wide range of laboratory and workshop. Now our teaching is relatively hands-on. Now these skills learned will be applied in their assignment, mini project, capstone project, internship, and final year projects. Now site visits are organized, industry guest speakers are invited to relate the technical knowledge with relevant industry. Now students are also involved with professional bodies such as IMEC-E, student chapters, and IEM student section. Now TARUC University College teaching medium is in English. Now through assignment presentation, technical report writing, viva, participation in extracurriculum such as inter-university competition, society activities. Now our students always develop excellent communication skills by the time they graduate. Now every year the demand for TARUC University College engineering graduates are overwhelming. Now TARUC University College engineering graduates are preferred because of our good track record for producing graduates with excellent technically as well as soft skill competency. Thank you.
All engineering programs in TARUC are industry relevant. The curriculum provides a learning experience that goes beyond academic knowledge. But only understanding the theoretical knowledge is not enough for an engineering career. A key component in our program is to integrate different ways for students to expose early to practice environment in their 4-year study. It is compulsory for students to undergo an industry training scheme during their study in TARUC. This is desirable for students to get a feel of the skill involved and familiarize with real industrial practices. The student will be placed in relevant engineering organizations and undergo a structured training and supervised by industry personnel. In TARUC, we have also placed a system to monitor and assess the student during their training period. Courses that are industry-linked, such as manufacturing technology, manufacturing, and operation management, are tied with industry visits. This thesis provides students a practical perspective of the engineering workplace. Many of these latest processes, large-scale or costly operation, can only be observed or demonstrated through the thesis. Also, for such first-hand engineering environment experiences, there is no substitute other than exposing students to the real industrial environment outside the campus. Other forms of engineering exposure are obtained through lectures, talks, or seminars by invited speakers from the industry. Guest lecturers, specifically practicing professionals, are invited to teach and share their experiences with our students. The seminar-style lectures or talks are desirable ways for subjects that have close ties with the industry. Thus, by emphasizing strong connection with the industry and its professional, our graduates are kept up to date and well prepared for the challenging role at the workplace in the future.
Hi everyone, I am Yo, lecturer from Departments of Electrical and Electronics Engineering, Tunku Abdul Rahman University College. Today, I am going to talk about is female suitable to be an engineer. After I graduated, I worked as a R&D software engineer. Since then, I started my life as an engineer. All I needed to do was to solve technical problems by using computers. It was a very comfortable working environment. Both my manager and senior manager were female too. They were just as successful as others. Few years ago, I decided to take the challenge of becoming a professional engineer. Therefore, I joined an electrical consultancy firm as an electrical consultant. It was quite challenging as I had to provide consultancy to the construction industry. Although this field was mainly supported by male engineers, I have met quite a number of female engineers. They have all contributed equally to the development of construction industry. Female can definitely be engineers. If you have the dream of designing creative solutions, and if you are passionate in problem solving, like to take up the challenges, and enjoy working in a team, then you are just right to be an engineer. Join us, and we will raise you as an engineer.